Hello everyone. Today lecture 8 is on time value of money and is presented by my group, the Four Musketeers.
Okay, so let's jump right in. What is a timeline? Well, a timeline is a visual way to show when money is received or paid over a certain period. Time zero is today, right now, and each point after that shows the end of a time period, usually a year. This helps us clearly see the flow of money and it's key part of understanding time value of money problems, TVM problems. Okay, so what can we actually show on a timeline? First, we have lump sums, like one single payment at a full point. Then we have annuities, where the amount is the same every year. And lastly, we have uneven cash flows, where the amount changes each year. Timelines like these help you stay organized, avoid calculation mistakes, and clearly see when each amount happens, which is super helpful before solving anything. Okay, so let's try one. You receive $100 at year 1, $300 at year 2 and 3, and you pay $50 at year 4. Your task is to draw a timeline and label each cash flow. Here's a reminder. Use plus for money you receive and negative for money you pay. Okay, so on the next slide, you see what your timeline should look like. Time 0 has zero cash flow. It's just the starting point. Then you have 100 plus 100 at year 1, plus 300 at year 2 and year 3, and finally minus 50 at year 4. Getting this part makes everything else, like solving for value or interest, way easier later on. So always start with a timeline when doing time value of money questions.
Let's look at present and future values now. Present value is the value today of a future cash flow or series of cash flows. It is calculated by discounting the future value by the estimated rate of return that the money could earn if invested. The formula is PV equal F future value divided by 1 plus R to the power n, where R is the interest rate and n is the number of periods. For this example, we apply this formula in the previous slide, but FV is 5,000 because that's the amount you're expected to receive 4 years from now. So that will be a future value. R is the interest rate, so it will be 1.08, and N is the number of periods, which is 4. This example is a bit different because every year you get different amount because as you can see at year 4, it is negative 100. So you have to calculate this differently. So we calculate by using the current value you have at now, which is example year 1, you have 150, you use that. The interest rate will remain the same for all 4 years, which is 1.1, but n is the number of period. It will differ every year. The previous two examples were on interest compounded yearly, so let's look at monthly now. Yeah, so 650 is a future value. And because this question is asking for monthly, 1 year has 12 months, so in 2 years there'll be 24 months. So the number of periods will be 24. So if we want to calculate the interest monthly, it's 0.08 divided by 12. And in the end, I'll get 554.19. Future value is the amount to which a cash flow or series of cash flows will grow over a given period of time when compounded at a given interest rate. It's calculated by compounding the present value using the estimated rate of return that the money will earn if invested over time. You calculate future value by using present value multiply 1 plus r to the power n. For this example, the present value is 570, r is the interest, so it will be 1.1, and n is the number of periods, which is 3. Similar to present value, we calculate the future value by using 100 multiplied by 1.1 to the power 4. 100 is the amount that you have at year 0, and 1.1 is the interest rate. Why it's to the power of 4 is because at year 0, you will earn interest for 4 years. That's why n is 4. And the same result applies for the next 3 years. What happens if the interest rate is compounded semi-annually? Let's take a look at the next example. For this example, because interest is compounded semi-annually, which means interest is compounded twice a year instead of once a year. So the number of periods is 6. So the present value is 600, interest is 1.03, and number of periods is 6.
Okay, and I'm back. Right now, we're moving forward to the financial calculator method. So on the screen, you see a very intimidating looking calculator with many buttons you might have not seen before. But don't worry, you just need to remember 5 buttons, and I'm gonna walk you through them real quick. So these are the five functions. N, that's the number of periods, like how long your loan or investment lasts. I is the interest rate per period. Remember, if it's monthly, divide the yearly rate by 12. PV for present value, which means how much your money is worth right now. PMT is your regular payment, monthly or yearly, like loan installments. FV is future value, what your money will grow to or what you owe later. These 5 work together like puzzle pieces. Once you have all of them but one, you can solve for the last one. Okay, and on the next slide, there are a few questions that you can answer, and the answers will be at the bottom. These questions are to help you see how each button works. You use this a lot in financial problems, so once you get the hang of it, you're golden.
Let's talk about annuities. Annuities typically guarantees fixed payments at regular intervals for a fixed period of time. What is the difference between ordinary annuity and annuity due is that ordinary annuity is a series of regular payments that is made at the end of each period, while annuity due is made at the beginning of each period. An example of ordinary annuity is stock dividend, and an example of annuity due is monthly rent expenses. So for this example, year 0, there's no interest rate, so it'll be 1,000. So we'll use 1,000 plus 1,000 multiplied by 1.05 to the power 1, and so on until n is 4. And you'll obtain the answer of 5525.63. So the previous slide was on timeline and formula method. So let's look at FC, which is financial calculator now. So for financial calculator, we have to input a minimum of at least 3 values. So for this question, we are looking at future value, so we leave future value empty. And as for payments, whenever you're using a financial calculator, the payment should be negative. It should be a negative value. So in this case, it will be negative 1,000. The annual rate is 5%, period is 5 years, so it's 5, and it's compounded annually. So after you input the value for payment, annual rate, periods, and compounding, you click onto FV and you'll get the value of 5525.63. Let's look at present value now. So we use the same formula to calculate present value. So it's 1000 divided by 1.05 to the power 1 until you get n equal 5, which will give you an answer of 4329.48. So for this example, you are trying to calculate what's your present value. So you leave present value empty. Same thing for payment, annual rate, periods, and compounding. So once you input those 4 values, you can click on the PV and you'll get the answer.
Now, we will learn how to make use of Excel to calculate for the present and future values. Here are the main inputs we will be using for Excel. The values required for each formula is the interest rate in percentage, number of periods in the time frame, and payment per period if there are any. Here's a previous example to illustrate it. As you can see here, the question is asking for present value, so we will make use of the PV formula. Let's give you a few seconds to try it out. Did you get it? So the key things to take note of is that your percentage should be included when typing out the formula. And when inputting the FV value, it has to have the negative sign in front of it for it to compute. Next up, the table method. There are separate tables for finding present value, future value, and PV and FV with factor of annuity. If you're using the table method, the table should already be given, so all you need to do is refer to it. Let's make use of the same question again. Since this question is asking for present value, we will refer to the PVIF table. Knowing that the interest rate is 8% and the period is 4, just refer to the table and find the respective column and row. Once you found it, it should be 0.7350. Then, you multiply this by the future value given in the question since we are looking for PV. So your final equation should be 280 times 0.7350, which will give you the final answer of 205.8.
Now I will be talking about the power of compound interest. Why is compound interest powerful? This is because even if you stop adding more money into the bank, your money will keep growing on its own. The longer you leave it in the bank, the bigger and the larger the amount it will get. This is why time is your best friend. Small amounts of money in the bank can actually turn into large amounts. So just leave it in the bank and let it grow. This is why compound interest isn't just interest. It's a financial superpower that makes your money multiply itself. Does compounding means more money? What is actually compounding? Compounding means you earn interest on both your money and the interest it already made. So your money grows faster over time. This means that compounding actually will make your money more. Let's look at the example on the slide. For the first timeline, it's actually compounded annually. What does this mean? It actually means that interest is added once a year. For example, let's look at the first timeline. You start with $100 and the yearly interest rate is shown as 10%. After 3 years, if interest is only added once per year, your $100 grows to $133.10. This means that the future value after 3 years is equal to $100 multiplied by 1.10 to the power of 3, which gives you the answer of $133.10. You might be wondering how I get this answer. So the $100 actually comes from the present value, and the 1.10 is actually 1 plus the periodic rate of 10%, which is also 0.10. And the 3 is actually the total number of compounding period. For the next timeline, it's actually compounded semi-annually. It means that interest is added twice a year. So let's look at the timeline. Similarly, you also start with $100, but instead the periodic interest rate used is 5%, meaning that the annual rate is effectively 10%. This is because since it's a periodic rate and its interest is added twice a year, 5% you multiply by 2 periods so the annual rate is 10%. Interest is added every 6 months. Why is it so? Because there is 3 year, so in each year interest is added twice a year. Therefore, because interest is added more often, your $100 will definitely grow into a larger amount. So for this case, it actually grows to $134. This means that the future value will be larger if it is compounded more often. Is it important to consider effective annual return, which is also known as EAR? Imagine you have a bank offering 4% annual interest rate. Even though the bank says 4% per year, your actual return, which is the effective annual return, will still get bigger as the interest is added more frequently. Why is this so? This is because when interest is added more often, like monthly or daily, the newly added interest starts earning its own interest sooner. For example, a 4% annual account might effectively give you 4%, but a 4% monthly account will give you a true 4.07% return on your money for the year. So next time when you're saving money, you want the interest to be compounded as frequently as possible because it will give you a tiny bit more money at the end of the year, even if the main advertised rate is the same. So always look out for the highest effective annual rate, but it's compounded monthly. But because bank A is compounded semi-annually, you get 2.5% interest added every 6 months, while bank B you will get 0.4167% interest every single month. But because they're adding small percentage like 12 times a year, your interest starts earning it on itself much faster and more often as compared to Bank A, where you have to wait for like 6 months before you earn a new 2.5%. This means that the EAR for Bank B will definitely be higher than Bank A. In conclusion, don't just look at the nominal rate, because nominal rate don't tell you anything as it can be misleading. And for periodic rate, it only shows you how much interest is applied each time your bank adds money to your account. Therefore, effective annual rate is the most important because it actually tells you the true percentage of your savings that is actually growing by over the entire year, also considering how interest is added. Thank you, and I hope lecture 8 on the time value of money is clearer for you now.